Figure shows the cross sections through two large parallel non-conducting sheets with identical distribution of positive charge with surface charge density sigma equal to 2.31 multiply 10 power minus 22 coulomb per meter square. In unit vector notation, what is the electric field E at point above the sheets, between them and below them? So here we have to see the diagram. Here we have two parallel plates, right? And these two parallel plates are non-conducting sheets or non-conducting plates. Let's take this is plate 1 and then this one is plate 2 or sheet 1 or sheet 2. And here if you see these two plates, in two plates we have identical distribution of positive charge. That means you can see all positive charges in plate 2 in sheet 1, and then here also we have positive charge. So the positive charge are distributed in both sheet 1 and 2. So what we are going to find, we are going to find the electric field in this location above the sheet, that means above sheet 1, and then we are going to find the electric field between sheets, between sheet 1 and 2, and then the third location is below sheet 2. So that means in this location we are going to find the electric field, but we have to give the answer in terms of unit vector notation. For understanding this question, let's just go back to our theory, what we studied from chapter number 23 regarding this question. So here we have two cases. So we have to, once you know these two cases, then solving the problem will be very easy. Solving this problem will be very easy. So let's take the case 1. So what is given in case 1? Here I have two diagrams. In first diagram, we kept two plates or exactly in a vertical view, and then here we kept the same plate in horizontal view, but concept will be the same. So here what we are going to find, we are going to find what should be the electric field left hand side of plate 1 and what should be the electric field in mid places, that means between two sheets 1 and 2, and then what should be the electric field to the right hand side of sheet 2. And here we have two non-conducting sheets which carries two different charges. In first sheet we have a positive charge distributed, and in second plate or second sheet we have the negative charge. If you see the formula for electric field in the left hand side of plate 1, we had the value E equal to 0. Likewise, in the right hand side also we will get E equal to 0, because this formula we studied in the theory. But between the two sheets we will get the formula here E equal to sigma over epsilon naught. So the formula here, so better I can write the formula here. Between the two plates you will get the formula E, which is equal to sigma over epsilon naught. This case is only applicable for the two sheets carrying different charges. So that means left hand side of sheet 1 you will get 0, right hand side of plate 2 or sheet 2 you will get electric field 0, but midpoint you will get the electric field which is E equal to sigma over epsilon naught. And the same case will be applicable for this type of diagram, but this time you will get the answer in terms of y-axis. That means if you see the three location, the first location is above the sheet 1, the second location is between two sheets 1 and 2, and third location is below sheet 2. So here the formula will be the same. In this location you will get the electric field 0, and here also you will get electric field 0, but between these two you will get the electric field formula E, which is equal to sigma over epsilon naught. Understand? But when you come to case 2, it's a little bit different. So here what we have two sheets 1 and 2, but in these two sheets we have the same charges, positive charge in sheet 1 as well as sheet 2. In this case it will be quite different. What you will get in the left hand side of sheet 1, you will get the value of electric field as sigma over epsilon naught, but it is in negative direction of x-axis, because we have to see the diagram like this, because here we just consider, so this is our minus x, this is our plus x. So that means in this place you find the electric field, but which takes the value of negative, And also when you see the right hand side of plate 2, you will get the electric field E, which is equal to sigma over epsilon naught. But this time your electric field in the positive direction of x-axis. But between the two sheets 1 and 2, you will get the electric field which is equal to 0. See the two cases. In first case, right hand side and left hand side, we got electric field which is equal to 0. But in the second case, you will get the electric field in the middle of the two sheets, you will get 0. So this is the only case you have to understand. But if you kept the same plate in the horizontal view, the same answer, but sheet 1, above sheet 1, you will get the electric field here as E, which is equal to sigma over epsilon naught, but this time it is the positive direction of y-axis. But here the electric field which is equal to sigma over epsilon naught, but negative direction of y-axis, because this time we have to see the diagram. This one is positive y and this one is negative y. Clear? But between the two sheets, we will get the electric field which is equal to 0. So keep this information in your mind. So the arrangement of the plate is very, very important, as well as the charge distributed in the plates are very, very important. Clear? Okay, now we go back to the question. So what type of diagram we have? So we just see these two cases. So here we have, you can see the diagram. We have two sheets, but in two sheets we have the positive charge. That means this diagram is exactly applicable for this question, right? So we will get some electric field in the top of the plate 1, and we will get the electric field in the bottom of the plate 2. So here this is our plate 2, right? So we will get some electric field in the bottom of the plate 2, but between these two plates you will get the electric field which is equal to 0, because the electric field experienced by plate 1 and plate 2 are both opposite to each other. That's the reason we got electric field 0 here. Clear? So now we will take this diagram for this question. Understand? Okay, now we can go back to the question. So now we know the diagram. What type of diagram we have here? We have two sheets. Sheet 1 carries positive charge, and sheet 2 again carries a positive charge. Now we are going to find what should be the electric field in the top of plate 1, what should be the electric field in the bottom of the plate 2, and what should be the electric field between the two plates. But we have to give the answer in terms of a unit vector rotation. So as we studied, we just go back to the diagram. What formula we have here? E, which is equal to sigma over epsilon naught. So better I can just use the formula here. So the first question, in this location, we get the formula E, which is equal to sigma over epsilon naught, but unit vector notation, it is in the positive direction of the y-axis. So we have to mention which is J cap. And also the unit for this electric field is Newton per Coulomb. Likewise, when you come to the middle, we will get the electric field equal to 0, because the field experience, the electric field by plate 1 and plate 2 based on the charges will be opposite to each other. So that's the reason the electric field will become 0 in the middle. But when you come to bottom of the plate 2, that means below plate 2, we will get the electric field E, which is equal to sigma over epsilon naught, and the unit is Newton per Coulomb. But the unit vector notation we have to make, because again it's a y-axis, but this time you have to mention the answer with negative y, because it is a negative direction of the y-axis. Because if you see the graph they clearly mention this is y-axis, this is our x-axis. Clear? So we have to consider the y-axis point of view. So this is the positive y, that is our negative y. So below the plate 2, you will get the answer in negative. And we already have the given, which is the surface charge density sigma equal to 2.31 multiply 10 power minus 22. I think so. Better we can go back and check the value again before we calculate. So 2.31 multiply 10 power minus 22. So let's see the question. 2.31 multiply 10 power minus 2. So the values are correct, right? So now I have to calculate location A. So what is our location A? Top of the sheets. So location A, I'm going to substitute the value in this formula, E, which is equal to sigma over epsilon naught. So the sigma value is given, which is 2.31 multiply 10 power minus 22 divided by the permittivity constant value is 8.85 multiply 10 power minus 12. When you divide these numbers sigma with epsilon naught, we got the answer E, which is equal to 2.61 multiply 10 power minus 11 Newton per coulomb and unit vector notation j cap, right? Because y-axis, positive y-axis. But when you come to B location, what is our B location? Middle, right? That means between them. So in this location, we have to find, as we know, electric field is 0. So it's directly the answer is equal to 0. There is no substitution. But the location C below the sheets, that means below sheet 2, we will get the same answer like what we got in A, but this time the answer should be negative. So I can write the answer directly. No need to go for substituting the value because the same formula, but only the sign we have to include. So E, which is equal to 2.61 multiply 10 power minus 11 Newton per coulomb j cap, but it is in negative direction of y-axis, so I have to mention the sign here. So which formula exactly we used? We use this one. Okay, so E, which is equal to sigma over epsilon naught. When you substitute the same value, you will get the same answer like what we got in A part, but the sign we have to include because they need the answer in terms of unit vector notation. So these are the three answers for this question. Part A, positive value. Part B, electric field 0. Part C, negative answer. Clear? So this is the answer for this question. Thank you.